Okay, can we start, Lakshmi? Is it okay, everything? Hello?
Sir, one more minute.
Okay.
People are joining.
Okay.
Go to the home page, Lakshmi.
Nandu,
Yes, sir.
meet அவரை எப்படி இருக்கு இது பவர் எலக்ட்ரானிக்ஸ் கம்ப்ளீட்டா பார்ட் 4 பண்றீங்கல்ல இன்னைக்கு பவர்
ஆமா சார்.
எலக்ட்ரானிக்ஸ்
பவர் இல்ல சார். நாங்க
சென்சிட்டிவ்
லைட்டிங்
டிவைசஸ்
டிடெக்ஷன்
பண்றீங்க.
பார்ப்போம். ஆமா.
Lakshmi, is it a home page?
Yes, sir, this is the home page.
Yeah, keep browsing. Okay, let's start. Let's start, sir.
Okay, sir. Hello, good morning, everyone. Sir, am I audible? Am I audible?
Yes, sir.
Yes, sir.
Perfect,
Yes.
sir. Perfect.
Okay.
Go ahead.
Good morning, everyone. On behalf of NFE, we welcome you all, the participants, for your support and active participation. So today we are having our 82nd webinar. This year, this is the second webinar for this year. So our presenter will be Mr. Nandu Gopan. You are all aware of his skills. He is a specialist. I will introduce him. He is a application specialist from Gopan Private Limited Company. He is a BTech degree and is currently pursuing master degree program, Master of Science at the University of Whitewater. He has delivered numerous seminars and technical presentations. He also presented a paper on international conference on lightning and electromagnetic and semiconductor materials. He has presented paper at 17th International Fire Conference. That is, article published was casualties due to fire in air conditioners. Yes, it's a very good study on its electrical parameters because we are having so many electrical fire and accidents from air conditioners. It's a very good article. Currently, he is doing his master's in research on hybrid energy systems. So these are all his more importantly, he is active in NFE and an youngster upcoming star for the NFE in presenting materials and papers. So regarding NFE, I would like to say that we are creating awareness on electrical safety, as you are aware. And our vision, I would like to repeat that to make every electrical installation free of accidents, such as electrocution and fire due to short circuits, and increasing the reliability of electrical installation. We are contributing to the saving of life and property and supporting a sustainable development. This is our vision. To accomplish this vision, we shall strive to achieve our vision through getting accredited for product and personal certification. This is our mission. And to achieve this mission, we are carrying out so many activities. We are having, as of now, 2,000 members from in our NFE, and we have conducted training so far. There are 32 significant technical seminars nationwide. It involved nearly 5,000 participants, and from the webinars, it attracted a participant strength of more than 30,000 engineers. Apart from this, we are participating, our members, most of our members are participating in BAS IS and IEC committees also, especially BS, ETD 19, 20, 30, 32, and 50, as well as NBC 2016 are all our important committees that NFE is contributing much. We also gone in MOU with ASPA and IFE. So these are all our activities. And our special program on capacity building is Electrical Safety Professional Certification Scheme. This is intended to build capacity for the electrical professionals in the field of designers, installers, and verifiers. One more activity is also going on, that is fault loop impedance testing. These fault loop impedance testers are categorized into 3 levels, 1, 2, and 3. And we are having an ambitious and a major project to be taken to be later this year. That is mass awareness program for students on electrical safety. So we will be coordinating with a large number of schools, say 2,500 schools and 250 engineering colleges for this year. So these are all our ongoing activities, and we request members to involve themselves in all activities, join large and participate and support our programs. And regarding this webinar, I request members all to put your questions in QA box, not in comment box, so that we used to see the QA box, because lightning protection is an important subject that will be dealt with by the presenter with reference to the latest edition of 2024. So this will be a additional feature and useful for all our members. With this, I would like to invite Mr. Nandu Gopan to present his webinar. Thank you, Mr. Nandu Gopan. It's yours.
Yes,
You
sir.
can
Thanks,
share.
sir.
Thank you, participants. Please feel free to ask questions and put all your questions in Q&A box. Thank you all.
Sir, is it visible? Yes. The screen. Pause it.
It's
Yes.
not visible, Nandu. You double click it.
Double click பண்ணியாச்சு.
Hmm?
It is still not visible, sir.
Not visible.
Okay, 1 second. I'll stop and. Now it should be visible.
Now it's visible. Go to slide.
Okay, sir. So I'm presenting it. So it is clear right now, no, sir?
It's clear. Good.
Okay.
Perfect.
Okay. Yeah, thanks. So, I'll be taking a topic, lightning protection for sensitive equipments and electronics as per IEC 62305 Part 4, 2024. This is the new edition of the 62305 part. So I'll not be touching on any other part. I'll be touching only on the Part 4 of the standard. So before we go into it, let's go through some basics. So types of lightning damages. So if there is a lightning which is gonna hit your building, then you'll be getting some damages. So one is the mechanical damages. The next type of damage will be injury to human beings. You will get resistive or inductive coupling, and you can get some shock for human beings. That is the second type of damage. And the next type of damage is induced appearing or induced over voltages inside the structure. So if there is any over voltage which is coming inside the structure, then your internal systems, that electrical systems, will get affected. That is the third type. And next one is malfunction of internal system due to LEMP. This is what we'll be seeing in this webinar. We'll be actually seeing the fourth point, failure or malfunction of internal systems due to LEMP. If you ask me what is LEMP, LEMP means surges due to lightning strike to the building or to whatever nearby. It is basically surges and electromagnetic field. So whatever type of surges which is coming inside the building due to lightning and electromagnetic field, So I'm classifying all those things into LEMP, lightning electromagnetic impulse. So this webinar will be actually concentrating more on the fourth point, how to protect your equipments from LEMP, from surges. So now next slide. So electrical and electronic systems are subject to damage from LEMP, lightning impulse, electromagnetic impulse. And the basic thing about lightning is, if there is any participant over here who have read part 1 of the standard, first of all, before doing any lightning protection to your building, you are supposed to first do something called lightning protection zone. We'll actually touch on this concept, lightning protection zone concept. So protection against LEMP surges is actually based on this concept called lightning protection zone. So we will go more deep into this. So if you ask me what are these zones, lightning protection zones, these zones are just, inside a building, you assign some space. You assign, okay, there is a room 1. Okay, this room 1 can be lightning protection zone 1 or zone 2. So that is what it means to be, to categorize. If you categorize a zone, then it will become a lightning protection zone. So let me explain in a more pictorial way, that will be much better. So you have a building here. I think you can see the screen. You have a building here. The blue color is the building, and outside is the outside structure, outside environment. So inside the building you have room 1, and in room 1 you have equipment 1. So how it works is, suppose in case of lightning here, you will get some H1 means magnetic, magnetic strength, magnetic field strength. So you will get some magnetic field in building. Inside the building, you will get some magnetic field. Let's keep it H1. And inside the room, there will be something else called H2. Again, magnetic field will be coming inside the room 1. This room 1, the magnetic field in room 1 might be lower than the magnetic field in outside the room, meaning H1 can be equal to H2 or H2 can be lesser than H1. And if this equipment here, this equipment 1 can withstand this H2, then it is safe, no problem. But if suppose in case, if this equipment can't withstand H2, then you are supposed to have another room 2, so that it is reduced to H3. So this is what LPZ zone concept also works in. So you will categorize this building as zone 1, this room as zone 2, and this room 2 as zone 3. So you will categorize it based on how sensitive the equipment is. If the equipment is not sensitive, it is just a normal motor, you can keep it in zone 1. You don't need to keep zone 2 and zone 3. You don't need to keep in, say, 3 rooms. And if you are asking me how this H1 reduced to H2 and H3, then I will explain in this slides what are the protective measures that can be employed at the boundary of LPZ so that this reduction happens. So this is just one example. This is just magnetic field strength. There can also be a lightning current, lightning impulse which can come inside this equipment. If there is any line which is going outside this equipment, this room or building. So this is the basic concept. Now, if you take lightning protection, for example, lightning protection zones. Lightning protection zones are classified into 2 zones: outer zones and inner zones. Outer zones is where, outer zones is called LPZ0, and LPZ0 is divided into 2, which is LPZ0A and LPZ0B. Now, outer zone means that if you are means that you will be subject to full or partial lightning current in places where you are subject to full or partial lightning current, that is called zone 0. Now, LPZ zone 0A means threat is due to direct lightning flash, and you will be subject to full lightning current. So you are standing in an open field. If you are going and standing in an open field, then it is called LPZ0A. And if you're standing under a tree, then it is called LPZ0B, because you are protected from direct lightning strike, but you won't be protected from the side flash or anything like that. So that is zone 0B. So in okay, I'll show a next slide where I can explain this much better. So for example, for outer zones, you have a terrace, and this picture, I'll explain you the picture. So you have a terrace, and in the terrace there is a equipment, there is a antenna system, and there is a pillar, and there is one more rod here, and there is one more rod here. So 1 and 3 means lightning rod. So there is a lightning rod here, and there is a lightning rod here, and this is the protection area of the lightning rod. So if you are inside this area, I mean, I'll take a pen. So if you are there inside this area, it is protected, and if you are there in this area, it is not protected. So in this picture, let's concentrate only on area 1 and area 2. So if you, in this picture, what is LPZ0A and what is LPZ0B? As I told before, LPZ0A means a place where you will get direct lightning strike. That means this area, these two, where I have marked 2, is where if anything is there, you are highly probable to get a direct lightning strike. And if you're there in zone 0B, you won't get a direct lightning strike, but this equipment which is there, it can be subject to partial lightning current. It can be subject to partial lightning current. There can be some induced currents inside it. There can also be sometimes, there will be some power lines which is connected here and here. So there can be some induced current in this field, but it will not be subject to direct lightning strike. So this is zone 0B. Now, as I told you before, that it is divided into outer zones and inner zones. So outer zone means lightning protection zone 0. In zone 0, it is classified into zone A and zone B. Now, if you go to the inner zones, inner zones are classified into LPZ1, LPZ2, and LPZ. It can go till N. Now, why we are saying okay? So 1 means you will be getting lightning current. You will be getting some limited surge currents, and that will be reduced by some SPD. From zone 0 to zone 1, you will get some lightning current, but that will be reduced by some SPD. In zone 2, you'll still be getting some lightning current or magnetic field, but it will be lower than zone 1. And in zone 3, you will still be getting it, but it will be lower than zone 2. So here I have put LPZ01 is more than LPZ03. That means the current, the surge currents or induced magnetic field H or I will be very less compared to this lightning protection zone 1. That is what it means. So till your equipment can withstand the impulse current, you have to do it. But for general cases, most of the equipments can be placed in zone 1 of the standard. It is not a problem, but we are talking about sensitive equipments and sensitive electronics. So for that, probably if you want a good lightning protection, you will need to do all these things. You have to categorize it by zone 0, zone 1, zone 2, zone 3, and you have to categorize the equipments. So now, okay, here I have, I'll just erase it a little bit. So if I'm going a little fast, you can just tell me, because I can't see the Zoom screen, because my screen is taking both places. So this goes on till the equipment can withstand the electromagnetic EMP effects of the building, of the lightning. So it goes on. It can go, if the equipment can't withstand in zone 3, then you have to go till zone 4 also sometimes. 4. So it depends. Now, protection of structure. Lightning protection, you can also classify it in this way. If you want to protect your structure, you can also classify it in this way. One is protection to reduce physical damage and life hazards. Another one is to protection to reduce the internal systems. I think I have explained this in the second slide. So if you want to protect to reduce physical damages or life hazards, which is LPZ 0 to LPZ 1. So this is where the protection to physical this thing applies. LPZ 0 to LPZ 1. So there it is called external LPS. So external LPS consists of air termination system, the down conductor, and the earth termination system. So I think most of the participants here, you might be knowing about these three things, because there are a lot of videos from the NFE, and there are a lot of videos outside also which explains about the air termination system, down conductor system, and earth termination system. And in this is also classified into external LPS and something called internal LPS. This internal LPS is actually for equipotential bonding and separation distance. So you're supposed to do equipotential bonding with the with the down conductor and also the internal systems. You're 100% you're supposed to do. So this is to protect against, to reduce physical damages and life hazards. Now if you come to the next one, okay, and one more thing, this part of the standard is actually coming from IEC 62305 part 3. There are 4 parts to this standard for the 62305 series. Part 1, part 2, part 3, and part 4. Part 1 is basics, part 2 is risk assessment, part 3 is the for protection against physical damages and life hazards, and part 4 is where this one second. Part 4 is this one. So I'll just show. So if you are taking protection to reduce the failure of internal systems, it is divided into LPZ 0, LPS. It is applicable in LPS 1, LPZ zone 1 to zone 2 to zone 3, or it can go more. So it is applicable in these zones. So this is called surge protective measure. This, in the standard, if you have read it, all the protective measures which you are seeing down, protection against LEMP, is called surge protective measure, not device. Device is something different. This is surge protective measure. So in surge protective measure, it is classified into first one. To achieve surge protective measure, you can, first one is magnetic shielding and line routing. Next is coordinated SPD system, and next is earthing and bonding networks, and next is isolating interfaces. So if you want to achieve a good surge protective measure in your building, you are supposed to have all these 4. Like example, in the external LPS part 3, if you want to have a good lightning protection system, you need to have air termination, down conductor, and earth termination system, and equipotential bonding. So you need to have that to protect against, to reduce physical damage and life hazard. And to reduce the failure of internal systems, you are supposed to have all these things. So in today's webinar, I will actually I will actually be talking about this part, and this part. I will not be talking much on the isolating interface, because there won't be much time. and this concept is just being introduced in the standard. So probably when the products are available for it, probably I can take a little more in-depth class on isolating interfaces. So right now we'll be taking on earthing and bonding networks, coordinated SPD system, and magnetic shielding and line routing. And okay, and this is also as per IEC 62305 part 4. So this is part 4. Part 4, actually, if you read part 4, this is what it explains. It explains this in a very detailed ways. So topics, I think I've already told this. So we'll be going on these topics: earthing and bonding networks, magnetic shielding and line routing, and coordinated SPD system. All these are called surge protective measures, SPM for short, SPM, surge protective measure, SPM for short. All these SPMs, you can either use all three together or you can use either one also, but I won't recommend using only one. You can at least use 2 or 3, it will be much better for your equipment to have a good life. And the standard also says something like this. I don't agree with it, but I'm just putting it for people's knowledge. You are going to get your internal systems is going to fail only if the power is on. If you off the power, then there's not going to be any damage to it. So that is what it says. It says that you can use something called thunderstorm warning system. It's a device. So when the lightning is going to come, this is going to warn you some time before that lightning is going to come. So if you have this system, you know that lightning is going to come. You can just switch off the TV, or you can just switch off the data racks. It is not practical, but it is still there in the standard for information purposes. So next one, earthing and bonding, the first topic. So I'll go a little deep on this. Actually, if you see, to be honest, in part 3 they will be explaining about earth termination system, and part 4 also they'll be explaining about earthing and bonding networks, because earthing is very important in this subject for reduction against EMI, this LEMP. It is very important, and whatever is said in part 4 is actually is as per the part 3 and also as per National Electrical Code of India, as per IS 3732. It is all interlinked. I can show you, I'll show some pictures in it in today's webinar, which all the things are interlinked. So why do you need earthing and bonding networks? So for earthing, you need earth termination systems. You need earth termination systems to disperse lightning into the soil. Obviously, you need that. And next one is bonding networks. Yeah. So you need bonding networks to minimize potential difference and reducing magnetic field. So you need both these systems. What it means by reducing potential difference and reducing magnetic field is, since if you will be doing a lot of bonding, and if you are doing a lot of bonding, the potential difference will be negligible. You have to make it negligible. So I'll show a picture now, which is I would say a very good picture, which shows a earth termination system and bonding network perfectly. So I believe you can see the picture. So if you see the picture, it is a building. Buildings, only the steel columns they have kept in this structure. And if you see this picture on a whole, here there is something called earth termination system. They are calling this is the earth termination system, and this inside mesh or this mesh, or this mesh is called bonding networks. So if you see this on a whole, if you zoom out and if you see it, you can actually say that all the zero reference points, all the points which should be reference to earth is actually connected together. Everything is interconnected, everything is connected so much that this potential difference which is said here, this potential difference is very very negligible. So this is what the picture is showing. It is everything is interconnected, and you can also see here they have showed bonding networks. In here they have put a bonding network of a big mesh, and here they have put a bonding network of small mesh. Here they have not even put a bonding network. So what this means is, depending on how low you want the potential difference to be, that's how you have to select the bonding network. Okay, so earth termination system. So I'll first explain on earthing, then I'll go to the bonding. So hello, I'm getting some noise. Okay, so okay, so earthing. I'll first explain on earthing, then I'll explain on bonding. So earth termination, earthing should be as per 62305 part 3. So in a structure, earthing is divided into two, type A and type B. If you have a simple house or something like that, you can use a type A earthing, but the standard recommends a type B earthing. So I'll explain what is type A and type B. So standard recommends type B earthing. If you have a structure with electronic systems, then the standard recommends type B earthing recommend. They are not even considering type A. They are considering only type B. So now if you ask me what is type A and type B earthing arrangement, so it is divided into two. Type A means the vertical and horizontal rods. I mean, you can go there, you can go outside and you can check that there are a lot of earth pits. So all the earth pits are actually type A earthing, vertical rods. If you ask what is type B means a ring in soil. If you have a ring in soil, it is type B. If you have a ring or a foundation mesh in the soil, it is a type B. It is a closed loop. So that is type B. Now I'll show you a picture. So if you have a system where you have a horizontal rod or you have a vertical rod, that is type A earthing. You can use it. You can either put vertical or you can put horizontal, or you can also put inclined, or you can put vertical plus horizontal. Whatever combinations you want to do, you can put. This is type A. Now type B. This is actually a picture from the site. This is a earthing housing structure, housing box, housing inspection housing, and this is the clamp, and there is a earth rod, type A vertical earth rod. Now, what is type B earthing? If you ask me, suppose you have this building, for example, and this is the top view of the building. This is how you see it from the top view. So, if there is a ring which is going around the building, there is a ring which is going around the building, and suppose that is this ring, and this ring is interconnected to the down conductors. It is called a type B arrangement. So all this down conductor must be bonded 100%. So this is a type B arrangement, and there are few requirements that it should be 1 meter away, 0.5 meter below. It is there in the standard in part 3. This is not the core of this webinar, so I'll skip it a little bit. And this is also recommended for electronic system, electronic installations. I explained in the previous slide. So this is few pictures of it from the installations which are done. So this is where there is a soil, they have dug something, and they have run a conductor down here. So there is a connection, and this is a foundation mesh. What they are doing, so they have done some exothermic welding, and they have done. So this is how it looks on site. Now on meshed earthing system. Actually, I would actually recommend the meshed earthing system, because the standard and the 60364 series of standard, they recommend this. The National Electrical Code also recommends type of earthing. So what it says is, you have building 1, you have building 2, and you have few towers. So what it says is, and you have some cable tray which is going from building 1 to 2. There's some cable trays. What it says is, all of the metal parts which is coming inside are actually bonded together, and they have put a mesh, and they have actually bonded together. This is what it means. So things. Okay, so a lower earth impedance will result in lower lightning currents entering the installation. So if you have a very pakka meshed system, I think the mesh spelling is wrong. If you have a very pakka meshed system, then the lightning which is entering the structure will also be reduced in a very small value. And also you can use the reinforced concretes or metal structures. You can use that to, you can use your natural metal you are using for the equipment. You can use it for the building. You can use it and make a very good bonding. And standard, actually, they have put a particular point in the 62305 part 4 series. They have put a point. The earth termination system, this is not can earth termination system can be improved by installing an additional earth point close to the connection point of the power utility. They have explained, they have put this clause on this earthing systems. So what this means is, you can actually see in this picture, there is a picture over here. So this is a meshed foundation earth system, and they are using the inside RCC, the steel reinforcement and concrete. They are using steel reinforcement and concrete to put the lightning down conductor or whatever. And this part, so yeah, this part 0.6 is what they mean. 0.6 is here. 0.6 is what they mean by earth point. So this earth point, they are actually, you can use it to reduce the impedance. You can use the this earth point to improve the earthing system of your installation. So if you are asking me how this earth point looks like, then I have few pictures. So this is how few of the earth point is. That is actually this earth point is connected inside the RCC of this structure, and they are actually bought outside. In this picture, they have put some copper bus bar and they have connected two points for probably for power utility. It might be going for transformers or whatnot. And here there is some GA steel which is connecting to this. So it can be done, which can improve your system in a very reliable way. So now we have finished with the earthing point. Now we are going to something called the bonding networks. So why we need bonding networks? So bonding network, it creates a low impedance bonding network to avoid dangerous potential difference between all equipments inside the inner LPZ. Bonding network also reduces magnetic field. The bonding network can be arranged in three-dimensional meshed structure with a typical mesh width of 5 meters. Basically, if you have an RCC steel, you can also you can put some superimposed conductors, and you can use that RCC steel for bonding network purposes. You can put a earth point nearby, and that can be very efficiently, you can control this potential difference. Now, so where and all this bonding is required, you are supposed to connect all these points, whatever metal things, metal components which is coming inside the building from one zone to another zone, you are supposed to bond it. If there is some metal facades or metal frames or elevator rails or cranes, whatever is coming from zone 1 to zone 2, you are supposed to bond it thoroughly. And next is bonding bars. So this, I think I explained it again. So all the bonding bars and magnetic shields of LPZ shall be integrated in the same way. So everything is interconnected. That's what it means, to be honest. So bonding network is of three types: star topology, mesh topology, and ring topology. There are three. If you classify the bonding networks, it is classified into three types. Now, bonding networks using structural steel. This is a picture from 62305 part 4 standards. So what it says is, you can see one. This is a side view of a building, and this is a top view of a floor, common floor. So this is the side view of a building. They have crossed sectionally. They have cut it and they are showing it. So first is the air termination system, and this is some metal roof thing which they have connected to the air termination system. 3 is the reinforcement rod. This is the reinforcement rod. This is also a reinforcement rod. 3 is the reinforcement rod. 4 is the mesh conductor superimposed in the structure. So here there is 4. So it is the mesh conductor superimposed in the structure. 5 is the joints, and 9 is also a superimposed steel and reinforced in concrete with superimposed mesh conductors. And 10, if there is any ring electrode, if you require, then you can put a 10, or you can put a foundation thing. So this is actually a picture of, so wherever the line is going, that is where the superimposed mesh conductor is there in steel reinforcement. So for bonding networks, you don't need to put a separate bonding network. You can also use the RCC steel, but to reduce the potential difference, you might need to use the superimposed mesh conductors, which can be, a 10 mm copper bonded steel, or you can use some stainless steel. You can use that also. It depends. Now, I'll just. Yes, so conductors inside an RCC can be used for earthing and bonding. Now I'll explain more on the ring topology and star topology and mesh topology. First is ring. So what it means is you have a room and you have equipment 1, you have equipment 2, and you have equipment 3. Wait, I'll take one second. Yeah, you have equipment 1, you have equipment 2, and you have equipment 3. So what it means is inside a room, you can put a ring around the room here where it is going. You can put a ring around the room, and you can connect equipment 1 to here, equipment 2 to here, equipment 3 to here. You can do it. I think in most of the railways, if you go to the electrical rooms and all, they'll be doing like this type of topology, and they'll be connecting to a separate earth electrode. They should not be doing the separate earth electrode part, but this is the correct thing. They have put a ring electrode, and everything is bonded inside the room. Now, it is recommended that it is recommended to do additional bonding of this also, because sometimes this one connection here, one connection here, one connection here, one connection here might not be enough. So it is recommended to do some additional connections here. So there is some additional connections which they have done. So it will reduce the the resistance between this equipment and this line. So it is better that way. Or you can also do some interconnections in this type of view. Equipment 1, 2, 3, they have interconnected in multiple places, one here, here, which is also a very good system, which is much better than this one or this one. This is very efficient. Next is star topology. Star topology means, star topology means here there is no ring. What it is there is a one bonding point, and they are using this bonding point to connect equipment 1. I'll show it in a pen. So they are using this bonding point. They are using this bonding point to connect to equipment 1, to equipment 2, and to equipment 3. They are using it to connect. So there is only one point, and they are connecting to equipment 1, 2, 3. Here also it is 100% recommended that you can do additional connections like this. It is much better that you do additional connections. Basically, if you have you should not limit it to 1 or 2 connections. If you are having more number of connections, that much efficient the system becomes, that much efficient the resistance reduces, that much efficient the potential difference will be very negligible in those systems if you have multiple bondings. So this is what I mean by the low potential difference. So if you are not doing this, there will be only one connections. But If you are having more connections, there will be low potential difference. And also, if there is any EMI field which is coming, it will be limited in this place, equipment within the line conductor and this. So if you don't have this connection, suppose you take that you don't have this connection, then it will be limited in this area. So it will be quite high. The induced field will be quite high. So that's why you are supposed to have additional connections. Now, mesh bonding networks. So you have next is mesh bonding network. So what you do is you have an electrical switchboard, or you can also, this can also be some electronic systems. So you have two systems, the RCC, or you can put a mesh down below, and you can interconnect this part and this part. That is a mesh bonding system. So inside there will be multiple connections that, it will become a very low potential difference system. So that is what it means by a mesh bonding network. So, and this is also a very recommended practice, because the potential difference will be much lower compared to star or ring. Now, so this I have told, right? The multiple bonds, including structural seals, should be done to reduce the impedance of the resulting bond. So you are supposed to reduce the impedance so low. Now, if you are asking for examples on how a bonding network looks like, so I have taken few pictures from IEC 60364. If you are asking me what is IEC 60364, it is the standard for electrical installations. In India, we have adopted it as National Electrical Code of India, and IS 732. We have adopted that into these two standards. So if you open IS 732, you can actually see this picture. So what it means is, there is a lot of structural steel and all. Yeah. So there are a lot of structural seals, lot of equipments, and everything is interconnected. There is interconnection here. There's some mesh down below. All of this are interconnected. This is what it means. Or you can also find this picture in IS 732. So where they have given a typical structure, and in the typical structure they have explained one bonding network. So this is a mesh and a star point. So there he has put a mesh. Here he has put a star point bonding. Here this is a star point bonding, and this is a ring topology. This is a mesh topology. So they have given this picture, and everything is connected to a structural framework, and which is connected to the foundation earth electrode. So what it shows is, it shows a series of examples of bonding networks, and also it also includes the earth termination system inside this picture. You can find it in IS 732. If you have the standard, you can just open it. You can go to the, I think, 4.5. I'm not sure. You have to go to the EMI EMC part of the standard, and there they have showed these pictures, this picture and this picture. Next, if you're asking me more on how this whether I'm supposed to select a ring or star, or how I'm supposed to use the connector, what type of connector I'm supposed to use, what type of resistance I'm supposed to meet, you can actually watch this webinar. I will just, I think, I'll just put this in the group, in the chat box, so that will be much better. I've put this in the chat box. Okay, I think I can't type. I can't type it in the chat box, but you can actually see. You can actually go to the YouTube, and you can see this webinar where they have explained about how to do this earthing, and what type of connection, what type of resistance you are supposed to use. That they'll be explaining much clear in this webinar. So I'm not going to go more on it, because it is going to take some time. There are more topics to cover today. Next, bonding requirements. So just take a pen. Yeah. So bonding requirements. Any external line which is entering the LPZ 0 to 1 or LPZ 1 to 2 should be bounding. What I mean by lines is, if there is any power line or telecommunication line, it should be bonded. It should be bonded via a SPD. If there is any pipeline, or if there is any cable tray which is coming, or any pipelines or any HVAC system which is entering, then that also should be bonded. The metal component should be bonded if it is entering from zone 0 to zone 1, or zone 1 to zone 3, or zone 3 to zone 4. If it is doing some entry from one zone to another zone, you are supposed to 100% bond it. Why they are saying you are supposed to bond it is so that the surge currents will be it will be spread across the installation. So SPD shall be used for, and the potential will be same across the installation. That is also the major point why they are asking to bond, so that if you are touching any if you are touching any pipelines, if you have done a good bonding, you will not get a shock, because wherever you are standing or wherever you are touching with your other hand, that will also be in the same potential. So no potential difference. So that is why they are asking to bond it first. So you are supposed to use SPDs for bonding of electrical and electronic system. And if there is any shielded cables or metal ducts which is coming, then you are supposed to bond that also. Now, if there is any armoring which is coming, you are supposed to armor that cable in that zone, and you have to bring it out. Or if it is going inside an enclosure inside the LPZ zone 1, for example, then you are supposed to bond it in that enclosure, and you have to bring it out. And any extraneous conductive part shall be bonded at the boundary. This bonding, you don't need any big thing to bond. You can just bond it to a MET. MET means a bus bar. You can just bond it to a bus bar. You don't need to have some sophisticated things to do. You can just have a bus bar. You can go to the market, get a stainless steel or SS or stainless steel or copper or any other bus bars you are getting. Just cut it and do the bonding. Sorry. And this bonding bar's size, the minimum size is set in the standard. You can just refer to it. So they have set some minimum size. You can just follow that size. It's more than enough. And what I mean by bonding at multiple places is, if you have a home, for example, you take home for example. If there is power line which is coming from area 1, from the front door, and you have a telecommunication line which is coming from the back door, you are supposed to not only do in the front door, you are supposed to go to the back door and also have a SPD there also. If there is a pipeline which is coming from front door and also from the back door, you are supposed to bond both these places. So if there is multiple entries from multiple locations, then you are supposed to bond it at multiple places. That is 100% mandatory. So here I've put that all conductive services entering the LPZ and all those things. So this is an example of bonding. So this is a boundary. This is outside LPZ zone 1. I mean zone 0. This is zone 1 and this is zone 2. So if there is any mast railway or antenna system or electrical power lines or pipelines or telecommunication line, you are supposed to bond it. There's some SPD. You use an SPD and you bond it. Or here at all, you don't need a SPD. You can just bond it to the MET or whatever. And all these bondings are interconnected together. They should not be left separately. They will all should be interconnected together. So this is a schematic picture of a drawing where bonding is done at all entrances and all bonding bars are connected. This is a schematic picture. You can find this in the standard. So next is we are going to go to this topic, magnetic shielding and line routing. I think I'll go this a little fast because I think we are a little late. So magnetic shielding means, it's shielding. You're going to do some shielding. It's called spatial shielding. So it is a grid-like structure, grid-like shield mesh. They can be called as spatial shielding. For example, this is a room, and this room is connected with multiple meshes. So they are all interconnected together. So this is called a spatial shielding. Next is line shielding. Actually, if you wanted this spatial shielding, you are supposed to have probably 5 meter by 5 meter, or if you are connecting the RCC, it is more than enough. But if you wanted to do more calculation on this in annexure B of the standard, annexure B or annexure A of the standard, they have given the proper calculations on how to select the spatial shielding. I won't be teaching much on the calculation part, because if I'm taking the calculation part, then I need a separate another webinar to do that calculation part. It is quite complicated. Next is line shielding. So if you have it is shielding of internal lines or external lines. If there is any line which is coming outside or inside, you are supposed to shield it. So shielding shall be restricted to cable and equipments of the system to be protected. Metallic shield of the cable, closed metal cable ducts or metallic enclosures of the equipment. So there is some you can bond this armoring, or you can, this is a metallic cable tray, you are supposed to bond this place, or if there is equipment inside this enclosure, you are supposed to bond this enclosure also. Now, line routing, how we are supposed to do line routing. Line routing is very important. So you are not supposed to, you are supposed to have a line routing which doesn't induce any voltage in the line. So if you have a SPD and if you have a load, you're supposed to route it in this way, or you can do some turnings here. You can actually, you can turn it here and you can bring it, but you are not supposed to route it in this fashion. This is not advisable in any way, because if there is a lightning strike, due to the induced voltage, due to the current here, there can be some induced currents or voltages can be induced in this place. So it is quite dangerous. Example of another line shielding. Suppose you take this is a line and this is a P conductor and this is the SPD. In the standard, this is the bad apparatus. And I know in India, most of the places this is being done. And this is a very recommended practice. And this is the best practice you can get. Why this is a recommended practice is, in case of any surges, the induced voltage will only be in this area, in this small area. Here, the induced voltage will be very large. Here, it will be even more less. Here, it is even more less. So, this is the best line routing. So, if you are doing any line routing, take the P conductor, and P means earth conductor, and the line conductor together. Don't bring it separate. Don't separate it. Okay. That is the very important thing. You are not supposed to have a line conductor here and P conductor after 2-3 meters. You have it separate together. You are running a J strip, you run along with the conductor. Don't run it separate. Don't run 5-6 meters apart. It is not a good practice. Next is I'll give you some examples of what I have explained till now. So this is a first example is a good SPM, good surge protective measure. So you have a building. This is the building. So this is the building, and this is the outside air. So this is outside air is LPZ 0, and this is LPZ 1. Suppose in building this area, I've used the RCC steel and I've made a good shield, and I have also used external lighting protection system. So this is the shield. Next is I'm having room 1. And there also I have put some shielding. I've put a shielding here, shield LPZ2. So I've put some shielding, and this is LPZ2. And I have a equipment 3 at room 1. And there is some housing on metal body, and there is a power line which is coming. This is a power line. And I am bonding SPD in zone 0 to 1, 1 to 2, and 2 to 3. 3 means the equipment. I'm using the SPD here. So in case of lightning in here, lightning produces I0 and H0. I0 means the current and H is the magnetic field. So if that is being produced, here there will be some H0 in the LPZ0. And here there will be some H1. After this shielding, it will be going to H2. So here H0 will be more than H1 and H1 will be more than H2. So because you have done a very good shielding, so this is a good SPM. And also since you have put a good SPD, you have bonded in the internal this place, I0 U0 will be reduced to I0 UI U1 and it will be further reduced to I2 and U2. Here I have put I0 is so much more than I2. So this is a very good surge protective measure you have done in a building. So this is, I would say, is a Pakka system. Next, you have a surge protective measure. This is a basic SPM. You have not done any, you have a building, so zone 0 and zone 1. You have used a shield and you have put a LPS and you have equipment. So you're not keeping the equipment in room 1 or room 2, nothing like that. You're keeping it here. So you have a power line, you are using some SPD. So in case of lightning, I0 and H0, H0 will be outside and I1, H1 will be inside. So here, compared to the previous one, this is a little more redundant, a cost-effective solution you have done. So if the equipment can withstand this H1 and this I1, if the equipment can withstand the I1 and H1, then that is more than enough to have it in zone 1. Or if it can't withstand it, then you have to go to the basics, the previous slide. You have to put another room and you have to do all those things. So next, building. You have, this is a basic SPM with only internal line shielding. Okay. 1 second. So I'll just skip a little bit. So actually you don't see this. This is a mistake. So if there is a lightning strike in this structure, the same magnetic field strength which is there outside will be reflecting inside the structure if you have not done a good shielding. If you have used a brick wall or if you have not done a good shielding, it will be reflected inside. But you see the power line which is coming. If this power line is using some internal wires, if it is using shielding and you have terminated the shielding here, then there will be a reduction of H0 to H2 inside this shielding area. That is also possible. So here H0 will be so much lower than H2. And if there is any good SPD, then you will also reduce the surge here to the equipment. Example here like this. Now, if you are doing a SPM with only SPD, so you have a building and you have room 1 and LPZ 0, 1, 2 and equipment, and you have a line SPDs. In case of lightning here, since I'm not doing any shielding here or here or here, I will be getting the same H0, H0 and H0. The equipment will be fully vulnerable to the lightning field, like the magnetic field which is generated at the strike. Now, if there is, but since I have a SPD, good SPDs, this will be reducing to I2. So the I0 will be reducing to I2, but H0 will be remain same. This is what is most of the scenario in India. Like we have done a good SPD, but we have also done a good number of. We have also done most of the RCC steel also sometimes will be connected. If you have not, even if you are not connecting it, there will be a significant reduction from H0 to probably H2. There will be a significant reduction. But if you are doing some construction without the RCC steel, if you have not done a shielding, then the magnetic field, even if you have a good SPD, sometimes it might not be enough to protect the equipment. That is the key point here. Even if you have a good SPD, sometimes the equipment can fail, equipment can flicker in case of lightning. I think most of you have noticed some flickering or sometimes in case of lightning. But if you have SPD, most of the damages will be reduced because the surge currents will be minimized, and minimized. So the major problem will be reduced, but the magnetic field strength will still be there, so it can give you a small amount of problem depending on the equipment. So actually I will skip this part because this is how it explains for two structures, but I'll skip this part because it is taking some time. So this is also how we are supposed to do some extended zones. So you have a SPD here, and if you have a transformer, if you put a SPD here, then it will be LPZ1. But if you have a transformer inside and you are not putting a SPD here, then this place also becomes LPZ0. This room also becomes LPZ0. After that, it becomes LPZ1. So next part is the coordinated SPD system. I think I have little more time. I can finish it probably, hopefully. So before going to the coordinated SPD systems, there are two types of current impulses, 10 by 350 and 8 by 20. For the SPD, if you have a class 1 tested SPD, if you look in the side, they'll be putting something called I impulse. This I impulse is actually tested for 10 by 350 microsecond. And you can also see in class 2 tested SPD, it is very common in India. If you check that label also, it will be tested for I nominal. And sometimes optionally they'll be doing for I max. I max is, they are putting this 8 by 350 microsecond strike. They are putting one maximum time, and they are checking how much it can withstand. I nominal means it will be putting it repeatedly as per the SPD standard requirements. So it will be multiple strikes at I nominal. So if you're asking me what is 10 by 350 and 8 by 20, 10 by 350 means it reaches 10. In 10 microsecond, it reaches 100% of the current intensity. So if it is a 100 kiloamp strike, it reaches 100 kiloamps in 10 microseconds and 50 kiloamps in 350 microsecond. Same thing for 8 by 20, it reaches 100 kiloamps at 8 seconds and 50 kiloamps in 20 seconds. That is what it means by 10 by 350 and 8 by 20. So 10 by 350 will be a much large impact because of large time, that the energy, the power will be much more large compared to 8 by 20 with the same current parameters. So connection type 1, there are two types of connections for SPD. This is type 1. So you have line conductor, line 1, RYB, and neutral, and PE conductor. And this is the connection type 1. This is called 4 plus 0. So 4 numbers of SPD between RYB and neutral. So there will be live conductors and PE conductor. There will be 4 numbers of SPD between them. Next type of connection is for is 3 plus 1. There will be three lines of SPD will be connected to neutral, and one line will be connected to PE. For TT system, you are supposed to go with this 3 plus 1 connection. And for TNS system, you can go with either one. Maybe you can go with type 1 connection. But for TT, earth electrode earthing system, you are supposed to go with type 2 connections. And also, if there is any over voltages, type 2, only one SPD will play, but here all the SPDs will be failing if there is any over voltage. But anyway, that I'll not be explaining much. Yes. So if there is anyone who's asking for common mode and differential mode protection, yes, SPD will be doing that. Common mode protection means live conductor and PE conductor. Differential mode means between live conductors. If there is a SPD means, since there is a SPD here, if there is a potential difference between this line and this line, SPD will be working, these two SPD, all the SPDs will be working to give a equal potential. I'll explain in the previous slides, next slides. So SPDs will give common mode and differential mode potential. So this is few things which I will ignore. So how a SPD works in a current GPR. So you have a system 3+1 connection. RYB, it is connected to neutral, and neutral to PE, there is one SPD. This is a 3+1 connection type 2. So there is a lightning strike, and there is a potential increase GPR in the PE conductor. So what it does is, you see, this potential difference will be in so high voltage, because this is a lightning current. And then if you don't have SPD, there can be, the insulation between all these conductors will be going in a flash. So what happens is, SPD4 first will start working. SPD4 will work. It will make the voltage between neutral and PE same. So SPD works, and it becomes the voltage between neutral and PE for that microsecond, it becomes same. Next, SPD 123 will be working, and RYB and neutral and PE conductor will be in equal potential. That means the potential difference between all these four conductors will be equal. That means there won't be any damage, there won't be any insulation failure, or there won't be any failure in the cables or on the system, because the all the 5 lines are in same potential. That is what SPD technically does. They actually make an equipotential bonding. So if you think in a overall scale, if you have a building, you have an SPD, if the moment lightning strikes the building, the whole building will actually be in the same potential as the lightning, so that there won't be any potential difference should be negligible, such that there is no damage to the people, equipments, or the structure. That is what it happens. Now equipotential happens in nanoseconds. That will be this surges will be in microseconds, and this SPD works in nanoseconds. So you don't have to be any problem. The moment it comes, it will be on. It will be working. And there's something like this also. One second. Just check. Yeah. So there is something called. I know that there are a lot of people here. You'll be actually be confused on how to select the current I nominal or I imp of the surge arresters. How do I check it? How do I select it? Should I have 200 kiloamps or 100 kiloamps or 50 kiloamps? What should I do? That actually depends on how the risk assessment is done. So before that, I'll explain something called current distribution. It is a general assumption that if there is a lightning strike to your building, 50% will go to the soil, and 50% will be traveling through the power lines back to again the soil. It will be they just take a assumption of 50%. Generally, this won't be happening. Sometimes there will be, if you have done very good number of bonding, then this will be 90% and this will be 10%. It depends. It can be various, but generally you can take this assumption 50. So yeah. So I impedance, there is only one service line. So this I impulse for the SPD, if you are doing the lightning protection as per LPL1, then you have to have it for 100K or 75K or 50K. Depends. Now, if you have two service lines, then it can be 50. If you have one, this is one line. If you have another line, then it will be 50K, 75, 37.5K or 25K. Or if you have three, it will be reduced even more further. So there are several factors for it. Like for power lines, they sometimes take 5%, and for telecommunication line, they take 5%, and power line, they take 50%. There are a lot of factors for it. But mainly it depends on the LPL you are considering the building to be at. So this, you can consider this as a common thing for selecting the I impulse of the SPD at zone 0 to 1. I'm telling at here, at this part. I'm not explaining inside the structure how you have to put the SPD. I'm telling inside here in this part. So for 4+0 connections, you can have this impulse. I'm not going to explain it. You can, this is just basic divisions, 200 divided by half, then number of the, how many number of lines, that is divided by 3, 2, like those things. This is a common division which is happening here. So you can just take a calculator, do a small division, this will be happening. This is for 4+1 connections, you can have this impulse K rating, and for 3+1 connection, you can have this K rating. Now you have a one more thing, you have a structure and your lightning strikers have connected here, and there is a transformer here, and it is power is connected to HP. If the transformer is part of the building, if this is the part of the building, if it is inside the building, you don't need SPD1. You can also use SPD2 inside the building. So generally this side there will be some surge arresters, it is not a problem. If it is there inside the building, it is not a problem. But if it is there outside and the power lines are coming from top, then you will need SPD1 here also. Now if you are asking me, what type of SPD is required for buildings? Whether should I use class 1 tested SPD, or if I have to use class 2 tested SPD, what SPD should I select for my building? So it actually it depends mostly on the type of protection it is needed. Suppose you need protection against direct lightning. Suppose you have done some risk assessment and you say, okay, my building is probable to have a lightning strike, and you need protection against direct strike, direct lightning, then you are supposed to have class 1 tested SPD only where it is going from zone 0 to zone 1. So if there is a power line which is coming from outside to inside, you can have one class 1 SPD. If this power line is coming from 2 to 3 different ways, then you have to have how much our number of power line it is coming, you have to have that. But you are supposed to have only in one place, zone 0 to zone 1. Okay. And meaning, I'll just put a meaning also. Meaning, all power lines entering the building need type 1 SPD. So if there is any power line which is entering the building, you need type 1 SPD. And next, if protection against the direct strike to the building is not needed, if protection against direct strike to the building is not needed on but direct strike to the overhead lines is to be considered, then you are supposed to use class 1 SPD. So suppose you take a building, for example, you take a house, we'll take a house, everybody has. So if you take a house, for example, I don't want any protection for the house. Suppose if there is a lightning which is going to strike the house, and I don't care about the damages and I don't need a protection for it, it is fine. But there will be some power lines which is coming from outside, from the EB. There will be some power lines which is coming to your from your to your place. For that place, you are supposed to consider SPD. So for that power line, when it is coming inside your building, you are supposed to have class 1 SPD. At where this installation, electrical installation is being started in your building, you are supposed to have an SPD, class 1 SPD. That should be in zone 0 to 1. Now, where you are not needed to use, if you want protection only as against indirect strike, you don't want direct strike protection in overhead lines or for your building, and you care only about indirect strikes, which is quite large, then you can put type 2 SPD. You don't need to worry about type 1 at all. You leave about your type 1 and you can put type 2 SPD from everywhere, zone 0 to 1 or 1 to 2, 1 to 3 to 4, it depends. And in places where you have, so zone 0 to 1, it is clear. If you want direct strike protection, then you have to have class 1 SPD. If you don't want, if you are caring only about indirect strike, then you have to go for zone type 2 SPD. Inside the building, you are actually supposed to go for type 2 SPD. You don't need to go for type 1 SPD. If there is some sensitive equipments, then near the equipments, within 10 meters near the equipment, you are supposed to have you can have a class 3 SPD. That is much, it will be giving much more reliability for the equipments. So I think I have only 3-4 slides, so I'll just go a little fast. This is something called over voltage category. So every equipment is categorized into category 4, 3, 2. So transformer is category 4, the fixed installation is category 3, and connected equipment is category 2. And they'll be tested for this 600 kV, 600 voltage, 6000 voltage, 4000 voltage, and 2.5 voltage, 2.5 kV voltage they can withstand. Impulse kV they can withstand. Now there's something called class 1. I'll just skip it. So this is what I'm saying: Cat 1, Cat 4, Cat 2, Cat 3, Cat 2, and Cat 1 equipments. So if you want to check whether my equipment can withstand that area or not, the impulse current, then you have to select what type of category it is. Generally, all the equipments will be category 2. Industrial equipments sometimes will be category 3. So there is some formulas which I'll just explain. This UW is this 4000 volt, 6000 volt, or 2.5 kV. UW means voltage impulse withstander. So this much voltage, this much impulse, the equipment can withstand. That is what this UW means. So if I have a computer and this computer can withstand actually 2.5 kV of impulse, that is what it means. So there is a formula: UP by F should be less than UW. UP by F is voltage protection, impulse protection, which you are going to provide for this equipment. So if I'm going to provide, if the impulse which is going to come for the equipment, if it is less than 2.5 kV, then it is protected. That is what it means. So this is the how much protection you are going to give. UP is actually, you can is equal to UP plus delta U. This UP is actually what you can find in all SPDs. You can take a SPD and you can check that UP will actually be 1.5 kV. In all SPDs, it will be 1.5 kV. In the National Building Code, they have given that you are supposed to have UP not less than 1.5 kV. So it should be lower or equal to this. If you find any SPDs more than 1.5 kV, you just throw it out, because it is not going to protect it is not going to protect your equipment. Rather, the equipment is going to protect your SPD. That is the case. So all SPDs should have a UP of 1.5 kV, and this is 1.5 kV, and this UW point is actually the lead length. If you have a lead length of less than 0.5 meter, actually I'm highlighting this more. If you should have a lead length less than 5 meter, 0.5 meter. So lead length means SPD, you have a SPD and you have a wire here. So this should be less than 0.5 meter. So if you should have a less than 0.5 meter, then UW will be something, delta U will be something around 0.5 kV, and UP by F will be something around 2 kV, which is less than 2.5 kV. So it is good. But if suppose you have this lead length more than 1 meter, then this will be going to more than 0.5 kV. So that means if you have a lead length more than 1 meter, then there is going to be no protection. So I'll just skip it. This is how it looks in a top view: class 1, class 2, class 3. Appavoo sir, am I taking a little more time, or
No, you can finish.
okay? Yes, I'll
Yes,
just
it will.
finish. Yes. This is a picture. So this picture, you have a building. So when there is a power line which is entering the building, if you want a protection against direct strike, you put a SPD 1 here, SPD 2 here, SPD class 2 here, and if you want, you can put a SPD class 3 here, or you can also put class 2. It depends on you. If it is a sensitive equipment, then you can put class 3. And this meter between this and this should be less than 10 meters. That is important. So this is how it looks in a schematic representation. Now This is few of the. I just want to explain a little bit. I just want to show about Cape SPDs. So Cape, we have our own branded SPDs for this. So this is Type 1 tested SPD with VDE, and this is Type 2 tested SPD with VDE certificate. So while coming for Elakrama, if anybody is there, you can probably visit this place, visit us. So these are the other SPDs. I don't want to take more time on this. So this is Type 1, Type 2 and data line and power SPDs. Now, I want to finish this webinar by showing this image. This image is actually from 62305 part 4. I would say this is a very paka representation system, representation diagram of how it shows a LPS needs to be done. LPS and SPM, lightning protection system, and surge protective measure should be done in a building. So this is the picture for it. So let us just analyze this picture and close off this session. So this is a building. So this black color, wait one second, I'll just take a laser pointer. So yeah, you can see the laser pointer. So this black color point is the building. The building has been categorized into various parts. So this place is LPZ1, LPZ2. Inside this, it's LPZ2. This is LPZ1. So it is being categorized in various parts. Here it is categorized as LPZ0B because there is a mesh termination system. This is LPZ0B 0A, and this is LPZ0B. So this they have classified into that way. There is some power line which is going in this on the roof. There is some power line which is coming from for the camera. There is some power line which is coming for the telecommunication and LV line. And there is some transformer which is here, and there is a power line which is coming inside the structure, and it is everything is steel reinforcement in concrete. All of it is steel reinforcement in concrete. So what happens if you see this picture clearly? First bonding, if you take bonding for example, first earthing, if you take earthing for example, there is a foundation earth electrode. The transformer, they have some bonding terminals. You see, this is bonding terminals. So there is some bonding terminals here and here. It is connected to the steel reinforcement in the concrete. This part, the bonding terminals are connected to the steel reinforcement. So transformer's body and probably depending on the system, I think neutral will be connected there. It is connected to the steel reinforcement in the concrete, and then it is connected to the foundation earth electrode. So everything is paka. Very good. Next, they have given multiple bonding places. So if you can see, there is a bonding they have done to the steel facade. They have bonded the external lines. They have bonded the telecommunication LV lines. They have bonded even the equipments. These are equipments, and they have bonded the body of the equipments to the steel reinforcement. Here they have bonded. They have bonded here. So bonding is again here you can see equipotential bonding. So they have equipotential bonding. So they have bonded that in multiple places. So bonding is done paka. This earthing is done paka, and also the magnetic shielding. Shielding also is also done paka because they have connected the structural steel. There's a structural steel here. There's a structural steel here. So magnetic field strength is also being reduced. Here also there's a structural steel. So magnetic field is being reduced. So three things are now very good. Next is they have also put SPDs wherever it is required. So from zone 0 to zone 1, there's a telecommunication line, LB line. There is some this area and this area. There's some LB lines which is coming, and even this areas. There they have put a type 1 SPD. One second, I'm just the blue color marks are the type 1 SPDs because it is going from zone 0 to B. And here in these areas where there is a equipment from class 2 to here, it is actually class this is a small mistake. So in these areas, class 1 to class 2, class 2 to class 3, all these areas they have actually put a type 2 SPD. So this is a proper LPS and SPM requirement. And if you are asking me how lightning protection is done here, they have put a air termination mesh here. So air termination is done. Down conductor, they have used the steel reinforcement as down conductor. So down conductor is done. And next is foundation earth electrode they have connected. So earthing is also done. And equipotential bonding is also done. So internal LPS is also done. So LPS, all the things, external, internal LPS is done. Pakka. SPM, coordinated SPD, bonding, earthing, magnetic shielding is also done. Pakka. So this is a very good schematic picture on how a very good lightning protection system as per 62305 part 3 and part 4 needs to be done. That's how this explains. Now, yeah. So I'll just any questions if anybody has, probably you can put a message to me in this number, or you can also write to me in the email ng@capeindia.net. So, one second. So, Appavoo sir, can we start with the questions?
Yes,
Can I
yes, yes.
stop
Thank you.
screening?
Yes.
One second.
Nandu Gopan, you have given a very good and enthralling session because people are interested in lightning protection, especially for the sensitive electronic devices. You have given a comprehensive manner how to protect in an optimum manner. More
Yes, sir.
importantly, the bonding, star, mesh, and multiple parallel grounding, because multiple parallel conductors are required in such radiated frequency ranges. So
Yes, sir. Actually,
shielding
yes,
you have and the selection of SPDs, and more importantly, the method of connection will be given. So it's a very good session. Now I will go the question. There are 20 questions. I will go through one by one. Nandu,
yes, sir.
Nandu,
Yes, sir.
so the first question is from one Mr. Itala Narendra. He has put a question: can we get a list of equipments segregated based on zones from any code?
Okay, actually, you will not be able to get this anywhere. They have not segregated based on. They have not segregated the equipments based on zone. So equipments are actually, they have categorized into category 1, 2, 3, and 4. You can take the equipment and you can just, just look into the back in the data sheet anywhere. They'll be putting it category 2 or sometimes 3. Rare scenarios, there will be category 1. So what you have to do is when you're designing this SPM, you have to make sure that this SPD, the UP value is less than this 1 point, less than this category 3 equipment, and you have to also make sure that the magnetic shielding is there. In case it is a category 1 equipment, you are supposed to have a good magnetic shield. But for your question, they have not segregated based on zone, so you have to see it based on 4 voltage categories.
Okay,
Yes,
thank
sir.
you. Next question is from Pallavi Mukherjee. One more question in between.
One more question.
Yes, Pallavi Mukherjee has asked how to identify lightning arrestor in residential building. Also, one sub question: what's the thumb rule for how much radius does the lightning arrestor cover? And another sub
Okay.
question: can building have more than one lightning arrestor?
Okay, actually,
So,
this is not the topic of today's webinar, but I'll
yes.
just give a small brief. The how do you arrest? How do you identify a lightning arrestor? Actually, you can just see a rod on top. So if there is a rod, if I think that is what you mean by lightning arrestor. So if there is a rod, that is a air termination system, or it can be also a mesh. Sometimes in few places there won't be any rod or mesh. If there is a metal roof, they'll be bonding that metal roof. That is also an air termination system. And sometimes, and what is the thumb rule for radius of LA? That is actually a complicated question. It depends on rolling sphere radius, rolling sphere method. So for LPS level 1, 2, 3, there is a different radius, 60 meters, 30 meters, and 20 meters. They have different meters for different LPL levels. And building should have more than one lightning arrestor, 100%, because first of all, I don't, only if it is a very small building, then you need to have two lightning arresters, because Without two lightning arresters, then you will not be able to do the rolling sphere method properly. You will need to have two, at least. Yes, sir.
Okay, okay, thank you. Thank you. There's one more question from Jay Patke. Elaborate lightning event or strike. Is there any data sheet?
You can actually refer to part 1 of the standard. Part 1 of the standard, they give the correct parameters of lightning, and they have given the specific energy, the dA by dt, all those things they have given. So you can refer to part 1 of the standard. They give a good definition, good answers for that.
Okay. There are questions from one attendee, Mr. Balu G. Is an earth pit necessary for every down conductor? For example, if there are 10 down conductors in the building, can we provide 5 numbers earth pit after connecting them to the ground?
No, you are supposed to, for a type B earthing, if you are putting an earth pit, then you are supposed to have, if you have 10 down conductors, you are 100% you are supposed to have 10 earth pits. That is mandatory. Or you can also go for a type B. You can put a ring around the structure and you can connect all the down conductors. That is also possible.
Okay. And there is one more question from the same participant. Shall we use GA flat for down conductor?
As per the standard, it is allowing GA flat, but one of the problems what I have noticed in my visits, there are a lot of, you can't expect it to last for more than 3 years. Most of the places, they are reusing the you are supposed to do maintenance regularly if you are using GA, and it is mostly corroded. So I won't recommend it, but standard says yes with the minimum cross section area.
Okay, thank you. Because galvanizing is not done
Properly.
in a good manner, properly in most
Yes,
of
sir.
the
Yes, sir. That is also true.
times. So another question from Shailandra Rani is in high-rise buildings, the external ducts are covered with metal grills and reach till top floors. These are not bonded. Will it affect efficacy of external lightning protection system?
Yes, it will. To be honest, you are 100% you are supposed to bond these things. Metal grills means if it is just a standalone grill, then it is not a problem. But if it is if it is reaching the top floor and all those things, then you are supposed to bond it. So first of all, if if it is accessible to people, then you will get like a shock hazard. So you are supposed to do equipotential bonding 100%. So that is there. You are supposed to
Okay.
bond it.
Oh, fine. So another question from Govind Jha. How do we do bonding physically?
How do we do a bonding? Actually, you can take a strip, a minimum cross section area. You can take a copper strip or GA strip, whatever. I won't prefer GA, but copper strip or stainless steel strip. You can just take it, put some holes into it, and you can take a wire and you can connect, a cable duct and that strip, and you can. So you can just do multiple connections. Do I need to show more on that? Wait one second. I have to open. Sir, can we take this question a little later? I can just show a
Oh,
picture.
yes. Because it requires some elaborate
course.
physical.
Yes, sir.
So one more, we can go to next question. One Mr. Apurba Mighty. His question is how to protect old building where conventional LPS was not installed. I don't know whether what he means.
I don't.
Conventional or um,
Actually, I don't
so
understand by conventional LPS.
yeah.
This
How
is
to
the
protect
only
old
LPS.
building. Uh, So leave alone this conventional or non-conventional, it will go for another debate. So any building, old or new, it should be protected as per IEC 62305 or
Yes.
2124.
Yes.
Okay, then question
Sir,
from
one
Pradeep
second, sir.
Dave. Oh.
Sir, for the Govind Jave, can I just show a PPT? I'll just explain it.
Yes.
It's for the bonding thing. So,
Yeah, sure.
yes. So screen 2. Okay. So I've shared a screen. This is a picture from, sir. It is visible, no?
Yes,
So this
visible,
is,
visible.
yes sir, this is a picture from IS-3732 or even in NEC you can find this. So what it shows is how to do a bonding. So you can, this MET, MET is not a big term. MET means just a metal strip. You take a metal strip and you connect, if there is a sub panel body, you connect that strip with a wire to the MET. You connect, if there is some down conductor, you connect it with this again a strip, again a wire. You, if there is a metal pipe, you connect it to the strip. Everything should be bonded. That's it. You just need to have a wire and you have to connect it all together to a strip. That's it. So it is not a complicated thing. Yes, yes sir, that is,
Okay.
I think,
There is one more question from Pradeep Dave. How to protect GIS building? Gas insulated substation building. Here it is.
you are asking for, in terms of lightning protection, or I think in terms of
Uh,
lightning protection only.
we have to infer the question. I think building protection, he requires building protection.
Yes, if you can just you do the normal whatever I explained you. For the buildings, you are supposed to do the air termination, down conductor, and lightning thing, and you are supposed to do the bonding internally. So that is more than
Yes.
enough to do protect.
Yes, you have given a descriptive manner how to protect the uh, internal side using
Yes.
mesh and various type of configurations. So one more question is from Agam Prakash. What types of method available to check the effectiveness of the existing earthing as it is underground?
Okay. What method available to check the effectiveness of earthing? That actually depends. If you are asking in terms of lightning protection, if you are having a type B earthing, if you have a type B earthing, that means a ring. You have to make sure that there is a, if you have used a GI steel, it might be corroded. So you have to make sure that there is a ring there. So what you have to do is sometimes you can do some basic continuity test, disconnect and do a continuity test that you can use. Or if it is a 10 type A thing, you can do a earth electrode resistance test for 10 ohm meter. It should be less than 10 ohm meter. Or if you can't do all those things, then what I would actually suggest is, in the standard they have included a new testing concept called high impulse testing. So it is actually a testing of very high impulse. Very high impulse, they'll actually be they'll be connecting to the building and they'll connect it to the soil. So they'll put a high impulse to the building and they'll check how much ohms, how much impedance, not resistive ohms, how much impedance the uh, earthing is. So you can use that thing also, impedance test, high impedance test, impulse impedance.
Uh, okay. So I would like to supplement your reply. Actually, the efficacy of earthing bonding, that is, it requires a specific device, instrument, a four-terminal instrument, where voltage is injected and current is measured. So this four-terminal instrument is suggested for such measurement. There are figures in NEC also, you can refer. So ultimately what it says is it should not exceed 0.2 ohm. It is between the air termination system and the equipotential bonding. It should not exceed 0.2 ohms. So this is possible if you use a proper device. So this is the thing you have to check. This is nothing but a continuity test prescribed in the verification for not only for the internal electrical wiring, it's applicable for the external as well as lighting protection bonding system also. It covers functional and equipotential bonding efficacy. So another question is from Mr. Balu. Is SPD require backup fuse?
Yes, you are supposed to use with backup fuse because in there is a huge probability of SPD failing in case of over voltage. And the problem with SPD is, if you have failed due to over voltage, then it will create a short circuit. And in case if the upstream MCB or MCCB, whatever the protected device is, in case it doesn't disconnect, then you will face with a huge serious problem. So you are supposed to use with backup fuse. It is better you use with backup fuse because it provides one more better reason is, In the standard, in the PPT, I have given another explanation on 0.5 meter lead length. This will help you very much immensely on that 0.5 meter lead length also. Yes, sir.
Okay. So now one question from Amirdlal Nambiar from Kerala State University. So what is the one second. Once you do all this, what is the verification procedure? What are the limiting values?
Okay, that is actually a very good questions, because see, we are actually looking this for electronic things. The standard, actually they have not given a value to say that it should be less than this or less than this. What the standard is saying is, if you really want to do a good protection for electronics, you are supposed to do simulations for it. Without simulations, it is not possible. They have given some basic calculations. I can show that part. 1 second. Okay, here it is. So if you, 1 second, sir, I'll just share the screen a little bit.
Oh, yes.
So yeah, so you can see the screen. If you take the standard annexure A, you go to annexure A. Yeah. So go to annexure A. They will actually be giving these values, rated impulse of the equipments they will be giving. But to actually verify it, in the design stage, you are actually supposed to do a lot of simulations. For example, they have given a lot of calculations here, how you are supposed to check the correct values of it. I can actually do a PPT on it, but I thought it will be too much to explain in this PPT. So you can, there are a lot of calculations they have told, which you are supposed to consider if you want to do a good system. And how do you, what is the next question? I think this is the verification procedure. They have actually not discussed in the standard, to be honest. Verification procedure for part 4. You can use some EMI. There are few testing laboratories. I use, I think, I forgot the name. It starts with yes. So they will come here and they will do some LEMP or they'll do some HEMP impulse, and you can do some test to effectively decide the shielding factor or magnetic shielding or induced currents or all those currents. You can, there are some testing there are some testing people who do that, but there are no values that it should be less than this or less than that. They have not given that value. It depends on the equipment. It depends on the simulation result while designing, sorry. Samir, yes, the people who do this testing, they are Samir. Actually, I forgot the name. They are Samir. Yes, sir.
Okay. So another question is from Satya. The question is, we have complained on neutral to earthing volt is high. Guide us on how to resolve the issue. Entire earthing is connected through structural earthing system.
Okay, actually, I would actually argue on this. The neutral to, if you have a normal equipment, a class 1 or class 2 equipment, if you have a normal equipment, neutral to earth voltage, it can also be 230 volt also. It is not a problem. So the, where this is a problem is neutral to earth voltage. Where this will be a problem is only on equipments where they have something called a functional alert. And this is actually a problem with respect to functional alert. Not if you have a motor or if you have some equipments or if you have some lights or all those things, neutral to earth voltage, it doesn't really matter. What it matters is where the equipments for functional earth is present. And in those areas also, neutral to earth voltage doesn't matter. What it matters is if you have a, what type of bonding networks you're using. So that is where this actually matters. Neutral to high voltage, neutral to voltage is not a problem. And one more thing, it depends on what type of system earthing also you're following. So if you have a TNS system, neutral to earth voltage won't be much high, but and it is not a big problem also. It is not a problem. Appavoo sir can give a better answer for this.
Yes. It's Satya, she is an active, she has brought in so many people so to this webinar. So what I can say is, there's a specific standard IEC 61200 where the how the functional earthing, how the earthings downstream of an UPS are to be made to avoid any noise earthing. So once you follow these configurations prescribed in IEC 61200, simply saying, for example, if there is an isolation transformer after the EPS, then you can derive a TNS from there itself. So this is referencing of the sensitive devices. They have their own referencing at the chassis. So we prescribe functional earthing. So it's a different subject here. But it is an important thing that we have already dealt with in our YouTube channel. You can see. So the important thing is neutral to earth referencing is more important than measuring the voltage. Because we have IT system, medical IT equipments are there where the neutral to, it is unearthed system. So the referencing is more important. You refer these documents 61200. Then another question is from Samit Thorat. Lightning arrestor is required for fuel storage tank yard. So today we are dealing with the specific subject of sensitive electronics inside the building, part 4. Anyhow, what do you would you like to answer on this?
Yes, you to answer it. Yes, you are supposed to use it, and you can refer to 6230 part 3. I think annexure C or D. In that, for fuel storage area, for EX area, they have explained in that annexures. You are 100%. You are supposed to have.
Thank you. So participant may refer the relevant annexure as per 62305 part 2. Okay, next question is yes, Pattaviram Suresh. His question is for an sorry, one more question I will miss. I will cover that, then I will come to this. There is one question from Harshad Patel. Can you explain size of down conductor of FPS system?
You can have minimum 8 mm, 8 mm square CSA is more than enough.
Okay. So it is it's not it's for the mechanical strength. For
Yes,
the
it is for
mechanical strength
mechanical
and
strength.
it's not a
8 mm is
current
minimum, but you can. It is recommended to have 10. You can have 10. That
yes,
is more than enough. You don't need to have
yes.
anything big.
So it should not erode away due to the normal external atmosphere and other things. Some mechanical rigidity should also be there. Then another question is from Pattabiram Suresh. For an independent house, is lightning arrestor provision a must?
Okay, this actually depends on your risk assessment. If you have done a risk assessment and it shows that it is not needed, then it is not needed. But if it is saying yes, it is better to have a risk assessment. If it is better to have a lightning LPS system. But if the risk assessment says no, then you don't need to have. But you are supposed to have a SPD 100% in the incoming power line. That is more dangerous than the LPS, lightning arrestor. That is more important.
Okay. One more question from Davis AR. In the case of an electrical room with ST panel, LT panel, and PLC and drive panel, can we connect all the earthing system for bonding, including the PLC reference earthing?
Actually, there are a lot of questions on earthing, and I think IS 3043 needs to be released fast, the new version. But yes, you are supposed to bond all those things together. And also the PLC earthing, it is called functional earthing. Functional earthing and the normal earthing, you are supposed to have it referenced through one insulated conductor. So that also should be referenced to earthing at one point.
Yes. So single point earthing and insulated conductor is required for such devices called as functional earthing. So this is the thing that we can say. So another question is from Uday Shankar Vasudevan. What type of bonding networks shall be considered while installing rooftop solar system?
Rooftop solar systems. Okay. If you are using a rooftop solar systems, then major thing is you are supposed to have it all. If you have it interconnected, it is more than enough. And the resistance, if you do a continuity test, and if the resistance is less than 0.2 ohms, that is also more than enough. You don't. If you put a mesh, it is better because sometimes there will be people walking and they can touch one frame and another frame, so there can be some step voltage or there can be some voltage difference at times of lighting. You can have a normal mesh, but even if you're not doing a mesh, it is if you connect it to the structural steel and you just bond everything together, that is more than enough. You don't need to have like the ring or star topology. You just bond everything together, that is also more than enough.
Fine. So another question from Praveen Mark. What should be minimum rating of SPD? That you have given, explained in all your slides, different type of rating of SPDs for different locations. I think we can, it requires a more elaborate thing. It is already explained. Anyhow, I will go to the next question.
What is the material is
Used in construction of building for earthing.
You can use stainless steel or copper bonded conductors. It is, as long as the minimum size is met as per 62305 part 3, you can use those conductors.
So more questions are from 3043. As you said, we can wait till March where we can see a new and fully answered
Everything
queries
standard.
on earthing. It's a new thing. We can enjoy reading that. So another question from Ved Prakash. Can we connect the LPS earth pits connection with the substation main earth grid?
You are
If
100%
not, then
okay. You are supposed to connect all those things together. It is called equipotential bonding, and you are supposed to connect it together.
so interconnection is the mantra here.
Yes, yes.
Okay, people are hesitating to connect and separate. That concept should go. That is a myth. We have to interconnect. Unless we interconnect, we can't achieve any eco-potential bonding. So another question from Appavoo Mighty. Let me clarify about my question earlier asked. How to protect old building where conventional LPS was not installed? As we missed out the recommended earthing system installation in the construction phase, now in an operational building, what would be the challenges in implementation of a correct LPS? So he has modified the question.
Okay. You can just you can ask any people. You can have an air termination system, take a down conductor externally, and you can have a earthing system, type B earthing. You can put a ring. What is recommended is you have some connection point. What it does is there are few companies who have this connection point. What it does is it is like a specialized bolt. You can hammer this bolt. You can not hammer it. You have to drill it, and this bolt will give contact with the structural steel inside. So you can take a connection of the structural steel on the top of the building. You can take a structural steel connection with the LPS, and down of the building you can have another bolt which can take also another connection. So what it does is you can have a down conductor outside and this bolt on the top terrace and also in the ground floor. So it will give a connection in the structural steel also. That is a method you can use if you want to have connection with the structural steel. It's much better you do it.
Okay. So, Mr. Appavoo Mighty, I think you better to invite some consultant and have a site survey how the external and old buildings construction materials are utilized as suggested by Nandu Gopan. An easy solution has been given. However, it's better to investigate the size and risk assessment, everything of the building and go for mitigation. Then question from Ajit VS. Is any maximum limit for earth pit resistance for lightning arrestor? If yes, why?
They have given a maximum resistance of 10 ohms for type A earthing. But in case if you are not using a type A earthing is not recommended in NBC and in part 4 of the standard. If you are using a ring or mesh, if you are using a ring or a mesh, then you don't need, there is no minimum maximum limit at all. You just put a mesh. You don't need to, you just need to make sure that that's a proper mesh. That is all it matters.
Okay. Actually, this is the question raised by earth resistance value is one of the questions raised everywhere. However, there is a class in IEC regarding value that is applicable for type A. But type B is the recommended thing, is the most adapted thing for building, where it will serve not only lightning protection, it will serve so many other safety aspects also. And the potential grading of the building itself will be reduced. Potential touch potential itself, when a person approaches from substation to the building, it will get reduced. So this is a thing why we provide a strip around the building type B itself, earthing system. We do not think, we think that electrode alone is the earthing system. Strips are giving a very good earthing system to reference the thing and to discharge the lightning protection equally around the building instead of a pointed single point or 2-3 points contact. So another question is from Mr. Ved Prakash, is it mandatory or not for the provision of surge counter in conventional LPS?
Yes, it is. It is better you have a surge counter in your building, because sometimes you are designing your LPS for, sometimes you will be designing for LPL level 4. That means you will be designing for a small number of small current. If the lightning current is going to come above, suppose 50 kiloamps or 100, above 100 kiloamps, it is going to come above that, then it might not protect. So if you have a surge counter, it can at least measure how much lightning strike is coming and all those things, and you can also use it for insurance purposes. So you need to have a. It is recommended you have a surge counter. If you are not having it, again it doesn't matter.
A question from Munir MP. Which type of SPD connection is preferred for IT earthing system?
Okay, that is actually a quite. You can refer to the manufacturer. There are few manufacturers who have this system. Most of the SPDs they put TN or TT system, but IT systems also you'll be using an isolation transformer, and then only you'll be using a this medical equipment. So you sometimes you might need a SPD, but if you have a huge if it is limited to one small area, you might not need an SPD. You can put it in before the isolation monitor. That is more than enough sometimes.
Yes, this question we have dealt with in for the some other thing. In medical IT sense, it's IT system, we can call it as a medical IT system, for which measures are there by providing extraneous conductive parts with the already existing P conductors. This is not a TNS or TT system as Nandu explained.
Yes.
You have to provide a equipotential session by connecting external. The value should not exceed 0.2 ohms. So here the SPD connection is not permissible after the IT within the operation theater or patient environment. It may be applicable for the circuit inlet, circuit distribution end, not here. So you have to analyze and provide such things, because it is it should be analyzed. It's not. It can't be said that you provide IT earthing for patient is something, IT earthing for some other equipment is something else. So you have to analyze and go for the mitigation. Another question is from Satya P. What type of lightning arrest is recommended for the malls and shopping centers? Prasad Dalvi.
Actually, I don't lightning arrestor. If you are meaning rod, then it is recommended. The normal 62305 standard is recommended. I don't know
Yes,
what question means.
actually, lightning arrestor is not for, it is not a separate for mall
Yes.
one lightning arrestor, shopping center. It's not like that. It's for the building explained in 62305 part 3. Okay. One question from Chandrasekhar. Do we need to include SPD? one second. SPD in all power distribution panels if that is placed under Z2, Z3, zone 2 or zone 3.
Oh, okay. If there is if it is placed under zone 2, or if it is placed in zone 3, if it is coming from zone 2 to zone 3, then you are supposed to have SPDs in that place. Or suppose you are classifying the whole area as zone 2 and there is no zone 3, then you don't need to have that place. But if it is coming from zone 2 to zone 3 and there is a panel for all these power distribution, then you are supposed to have SPDs.
So another question from Vijay Gupta. How to do earthing in residential quarters of variable heights? It purely earthing matter.
You can ask a
Vijay-
consultant, he will do the
What's that? Okay. Then Praveen asked another question. Vendor is asking the earthing and neutral voltage not more than 1 volt for installation of HPLC equipment. Let me know any reference if you have in IEC to convince him.
Sir, I think you can answer this, sir. And
You
we
can,
answered.
Mr. Praveen Mask, you can say there is no IEC which prescribes limitation of neutral to earth water. Is it right? Can we say this, Nandu?
Yes,
There is
yes,
no
sir.
IEC.
Yes, sir. Actually, what you can ask is if the equipment, if whatever HPLC equipment it is there, you can ask what standard it is as per. It will be as per 100% IEC standard. You refer the standard. There itself, they will not be giving this requirement at all. It is more than enough.
So in simply what we can say is referencing. Again, we are coming to the referencing. Referencing, once the referencing goes out, then these problems will arise, not the voltage. So once it is referenced for single point earthing, star, mesh earthing, and multiple parallel earthing for radiated emission, these problems will be overcome. So another
Yes.
question is from Chetan Pawar. During testing, we need to remove the connection.
Okay, this is actually very vague, but I will consider that you are asking a continuity test. Then you are supposed to disconnect the test link and you are supposed to do, or if you are doing a earth resistance test, you are supposed to disconnect the test link. If that is what you are asking, that is the answer.
Testing of what we don't know. Anyhow, we can presume if it is earth electrode, then there are contactless removal is not required. You can have some window type, tongue tester type devices, CTs. You can clip on and measure the
Yes.
earth electrode. It is applicable for ESV substation for a periodical check, not for the LV insulation or lighting. So another question from Satya, is there any basic checks mandatory as per IS? If yes, can you share the implementation for old building?
You can actually refer to IS NEC 2023. Mandatory checks, if you are asking for electrical installation, there are some there are some testing you are supposed to do, testing and verification you are supposed to do. So you can refer to NEC 2023. So there they have put what type of test you are supposed to do at every stage. If that is what you are asking, or if you are asking for LPS, then there is this continuity test you are supposed to do and earth resistance test for type A.
Yes. So verification is there in the IEC as Nandu explained. So one more question from Chandrasekhar. Additional to the SPD at distribution, this is specific to the automation panels. So it is specific. PLC or SCADA and IO panels, power distribution panels. I couldn't understand.
Nandu, we have almost a 2 hour 15 minutes. People are dropping. So only
The
relevant
last
questions சீக்கிரம் முடிச்சு நம்ம முடிச்சிடலாம். 2.5 hours ஆச்சு.
The last
Okay, sir.
question.
I think last question, sir.
Okay.
So additional to the SPD at distribution, this is specific to automation panel and SPD. You are supposed for these things near these PLC, SCADA, and IO panels. You are supposed to have Type 3 SPD. So near you, it should be close to the equipment also. It should not be 10 meter away. It should be very close to the equipment, and you should have a type 3 SPD. So
Okay,
for these
that's
things,
all.
it is recommended.
Hmm,
Yes, sir.
fine. Nandu, it's an elaborate and comprehensive. I think we have satisfied all the participants by replying the queries. And there, we couldn't attack the multiple questions from one person in as an anonymous attendee. I request the participant to disclose their names and everything so that it will be fruitful. Now, we are not refusing those questions, but this is covered by other people's queries also. In future, we require a complete detailed name of the attendee who is doing. Because of a lot of questions, we couldn't cover all those queries from what do you call anonymous attendees.
Anonymous user.
Anonymous. So it was a very good and interesting session. You covered the latest edition, especially 2024 IEC 62305. People should be aware of this latest edition and see the changes and apply their practices in accordance with the international practices, IEC 62305. So with this, we can close this session. Thank you all the participants. Thank you for your support. So we are closing this session. Thank you all. Bye-bye.
Thank you. Yes.